The cognitive neuroscience of social emotions, pleasure, fear, and anxiety. So we are going to enjoy first to talk from Morten Kringelbach about empathy in music and dance, the role of pleasure and emotions.
Thank you so much. This is a truly wonderful, can you hear me? It's been a truly wonderful conference. For my liking, there's been a lot of focus on the negative emotions, so I thought maybe bring in some of the good things that crowd and collective emotions can do to you. And I'm obsessed with pleasure, so I hope I might give you some insights, because of course, understanding the positive system might help us understand what goes wrong. So perhaps we should start with something that evokes a lot of emotion in me. This, for instance. Dun, dun, dun. Let me just see. I'm doing the wrong thing here. Let's just do this. Not doing it. Hang on. That's better, isn't it? Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Break it down now. Dun, 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 dun. Dun, dun. Oh no! It's kind of hard not to get engaged with that. It's hard not to see that there's something collective going on here, and that it could potentially be the root of not only pleasure but also potentially some interventions. So in a sister conference that we organized last month, we tried to look at music and dance from different perspectives. And for those of you who weren't there, I can tell you missed something quite remarkable. We had lots of great people talking. I just give you some of the highlights, just to remind ourselves what it is that we are studying and why it's important. Perhaps a good place to start would be with what happened in the break. This is the Institute for Advanced Studies being converted into a dance session. All the fellows came down and saw it. It was quite remarkable, but of course this was the kind of things you see elsewhere. Singing. Now this is Jerome Lewis' work. It's polyphonic. And one of the interesting things about the Pygmies is they don't actually have different words for dance and music. It's the same word. They have different genres, but they don't have different words. So of course that, I think, points to how crucial they are. So I think those are the kinds of things that came up, and it became very clear that music really is for collective emotion, whether in the bonding between infants and parents, whether in karaoke, or whether, almost any kind of experience. And of course, this is what brought people to the Bataclan to start with. It was to share in that collective joy. Now, unfortunately, of course, it turned the other way. And I think understanding what happens while we're having that joy, and also why it can be so devastated, I think might be a worthwhile thing to pursue. So in one of the places we do this is in one of the other places that I have a position, namely in Denmark, where we recently set up a Center for Music in the Brain, where we are trying to quantify these things, both in terms of behavior but also in terms of brains. So I'll talk a little bit about brains today. But first, I thought we should just think about what it is that music is doing to us. Here's one of the great legends. My students don't know who he is. I gave a talk the other day for 500 undergraduate medical students, and granted they were medical students, but I said, so you all know the hardest working man in show business. It was just a blank. But this, of course, is James Brown. And the guy who is talking about James Brown or music in general is Steven Pinker, who I admire and respect, but I think he got it completely wrong when he said that music could vanish from our species and the rest of our lifestyle would be virtually unchanged. And there is something crucial about music for binding us together, for evoking emotions, for being the language of emotion. And I think probably the best way of understanding that is understanding the groove, what it is that makes us dance in the first place. And in order to understand that, let's just play one of my favorite tunes from the hardest working man in show business.
Get down with my girlfriend. That ain't right.
I see the few nodding heads.
Wow.
You're not being German on me.
Hollin' cuss.
Interestingly, of course, the Germans don't have a word for pleasure. They have many. So why is this funky? Listen to the guitars. Yeah, it's difficult not to get into it. So why is it funky? Why does it want to make you want to move? Well, I think it's because of this kind of gestalt. Like what you see up on the right, you see either a phase or a vase, but you can't see both at the same time. You can either hear the meter, so the underlying meter, or you can hear the syncopations on top. So you either hear the underlying 4/4s or you hear the guitars going in the background. And that tension, that inherent tension is what is propelling you forward. And of course, this is what we are. We are prediction machines. We are people that basically survive because we're able to predict what might happen next. This, of course, is also potentially a source of great unhappiness. John Steinbeck, the novelist, talk about the tragic miracle of consciousness, how it is that the fact that we know that we're going to die one day and it's not going to be pleasant, basically means that we find it very difficult to be in the now. We're constantly worrying about the past or worrying about the future that we can't change. And one of the uniquely interesting things about music is that it probably keeps us in that moment if we are in the right kind of beat. And what are the right kind of beats? So Peter Wust, a professional jazz musician and director of the center in Denmark, and I and one of our students got very interested in trying to take these funk grooves. And so we midified them with a snare and a hi-hat, and we played people different kinds of beats. So let me do that to you. Here's an example where we don't have a lot of syncopation. It's kind of like a march, isn't it? It's kind of boring. It'd be kind of hard to dance to that. It's almost too predictable, right? I mean, you know what's going to happen next. It's too close to the meter. But what if you shift it a little bit? What if you move that beat and insert it into nice places? It's not quite James Brown, but it's pretty good, right? And it's just a drum. Which, of course, is what you saw from the dancers in the courtyard. Just drumming that makes you dance. So if as little is not great, a little more is a little better. What if we gave a lot of syncopation? That must be like cheesecake on top, right? Let's try it. But no, it's sort of wrong, right? It feels more like some kind of, unless you're into free jazz, of course, and cultural influences are very important. So what does that mean? So behaviorally, you can ask people about this, and we did this in an online experiment with people around the world. And what you find is that the experience of different kind of levels of syncopation follows an inverted U-shape, like, in fact, all pleasurable experiences. The medium grooves, the ones that made you move and made me move, was the ones that made people move in general. That's the one in the middle. And similarly, that was the one they liked. We'll get back to what that might have happened in their brains, because, of course, we couldn't help ourselves to put them in scanners. But let's just for a moment think about what it is that might be going on here. So I did something that I was very much warned against. I wrote a textbook recently about emotion. It's writing books anyway is quite stressful. You write this thing and you send it out into orphanage, and you only hear about it if it misbehaves. But it sort of made me think about all these various things that might happen. And of course, when you think about emotions in general, usually what you're thinking about is the kinds of expressions of emotions. Darwin talked about that. And usually people come up with at least 6 categories: contempt, sadness, anger, fear, disgust, and surprise. And notice how negative they are. And also notice how difficult And they seem to be able to find out what might be going on. So what people did was, there's a famous study by Fan and Al, which has been cited over 2,500 times last time I looked. Lots of blobs there for different categories. I'm not sure exactly what they mean by happiness, because it's very difficult to measure. I think they mean joy or pleasure. But notice all those kind of blobs. I mean, if this is not neurophrenology, I don't know what is neurophrenology. In fact, if I may remind you, this was all the sort of the rage many years ago, where there were different kind of bumps on your head, and that really is where things are. On the right here, I've shown you some of the blobs that have been linked to negative emotions, and particularly with depression. But I think we need to move beyond neurophrenology. We need to think about not just blobs, we need to think about what different parts of the networks in our brains are doing, both when we are on our own, and of course we're never really on our own, but also when we're with other people. So it also means that you can do a little bit, or you can do a meta-analysis in here from a recent study where we actually we pooled all of the studies that have been done, where people have been suffering from PTSD, and we then looked at, if we aggregated all of those studies, these are the kinds of parts of the brain that come out. But already there are problems, because of course, when you compare these groups together, if you compare people with PTSD, should you compare them with people that are trauma naive, or people that have had a similar kind of trauma but are not suffering from PTSD? And you get very different kind of answers. So again, I think we need to find strategies of movement beyond that. And in my laboratory, we still use these big scanners, whether they're MEG scanners, which is the one that looks like a hairdryer, or whether it's the big one, which is an fMRI scanner. But also we can actually intervene in the brain, and I'll show you a little bit of data what happens when you can do that. We can stick electrodes in people's brains if, say, the pain from a phantom limb is sufficiently bad, or they suffer from Parkinson's. But we can use that as a research tool. And we can combine that with various computational methods, which I won't tell you too much about, but it really means that we can probably come up with something that is better than just correlation, really more like probabilistic causality. So the contention then is that you have these very complex molecules, emotions, evoked in individuals, and that of course are synergized by the emotions of others, both positively and negatively. But in that complex molecules, there have to be smaller atoms. There has to be things that constitute those emotions. And in my way of reading the literature, I think that pleasure and pain, and specifically pleasure, the reward system, is probably key to this. And you might say, how could one look at pleasure? It turns out that one can look at pleasure quite objectively. You can do that in other animals. You can look at the kind of facial reaction in rats and humans. You can measure these things, and you can actually work out what is happening to the reward system. And so we've done a lot of research into this, and what is also clear about these kind of pleasurable experiences is that you go through phases. I haven't had any lunch yet, and so at the moment I'm wanting lunch. I'm thinking about how I should get some food. At some point there will be lunch, I'm sure, and I will actually start liking that. And after a while I will have too much, maybe with a bit of dessert as the high point, and then I can think about something else. So the contention here is that pleasure is really what moves us through these phases. And these phases are never enjoyed on our own. And the contention is also when things go wrong, as in PTSD or depression or bipolar, it's really an unbalancing, a problem with these processes talking to each other. And so really the reason why we do this is to understand the normal system in order to understand what happens in the unbalanced system. Anhedonia being the major proponent of almost all affective disorders, if not all. So we've done a lot of studies. We've looked at what happens with food, with social stimuli, when we're engaging with people, when we are taking drugs. Surprisingly, we were able to give crystal meth to undergraduates in Oxford without any ethical problems. We were also allowed to do gambling studies. Fortunately, we weren't allowed to do sex studies. That apparently we were meant to close our eyes and think of England. So this posed a bit of a conundrum for me, because of course if you're interested in pleasure, you have to understand this most prosocial of all acts. Although of course famously Woody Allen said that masturbation is like making love to somebody you really love. So I was sort of left in a conundrum, and even in Denmark, this most liberal of all places, it was difficult to get ethical permission for this. So I did what any sane person would do. I allied myself with the Dutch. And so a good friend of mine, Yannico Georgiadis, did a study where he looked at what happens with women when they either have orgasms or fake orgasms. You may want to know how did they know, but I'm sworn to secrecy, although we may be able to take that during question time. The key finding was that part of this reward network was basically changed when you felt the real pleasure, like having an orgasm, as opposed to faking it. And so, in fact, if you look at the whole literature on sexual behavior in the scanner, you can see that there are different networks, whether you are in a wanting phase, in a desire phase, whether you are in a aroused phase, whether you're in the plateau phase, or whether you are having an orgasm, or whether you have to think about something completely different. And the contention here is that if anything goes wrong with this process, you are unable to make the transition between each of these kind of states. So in addiction, for instance, you stay all the time in the wanting phase, and you find it very difficult to like anything. This, of course, is exactly what the data is showing. And if you suffer from PTSD, you may find it very, very difficult to even transition at any point in this cycle, suffering very badly from anhedonia. And so, just summarizing this in a Scientific American article, we showed the kinds of parts of the brain that were involved, but also the kind of neurotransmitters that are changing that. But more to the point, in rat models, and remember I told you that you can measure the amount of pleasure that rats get out of things like sugar water by measuring how many times they lick their lips or how many times they gape when they get negative things. Kent Barrage from University of Michigan, who is the world's expert on pleasure in rats, showed that there are basically a number of regions, and those are the ones I highlight on the left, that are like dimmer switches. If you stimulate those, you get more licking to the same amount of sugar water, and if you stimulate the cold spots, which are the ones in blue, you will decrease that. So there's a network of regions that are talking to each other, and you can basically turn people's joy up and down. On the right, I've shown the potential homologous sites in the human brain, most of them coming from neuroimaging. But of course, the real sort of problem here is to work out, are they the same, and are they affected in things like depression, like things in PTSD, and how does that then, what does that tell us about the actual process? In a lot of my research, and specifically that which is about what happens when you have collective emotions, of course, this is really the template for all of the kinds of interactions that we will have later on. I've been fascinated by this bond between parents, not just mothers, but also fathers, of course, and they're linked to the babies. So human babies are extremely vulnerable. They require extensive nurturing. We can't really not do something to them. And at the same time, we also know that the long-term health of both the baby, of course, whether you see this glass as half full or half empty, is really about those early 18 months. And if something is wrong on the part of the parent, if the father or mother has postnatal depression, which in our part of the world is about probably 10 to 15% for both men and women, unless you do something about that, unless you intervene with that, you will find that there can be problems. There will be problems, in fact. And yet, as I'll show you, there are ways in which, by understanding what happens to us as we are reacting to these babies, that we can actually help with this. But of course, also, if there's something wrong with the baby, if there's a tiny cleft, for instance, that may change the sort of collective experience of this dyad. So I've been fascinated by that. And in fact, one of the things I do in my research is I've conducted the first longitudinal study. Remarkably, the only thing that really unites all of us in here is that we all have parents, or at least at some point will have had some. And understanding what happens as we become parents, as we become experts in actually engaging with these infants, nobody really knows what happens. We have all sorts of ideas, but nobody has ever conducted a study. So at the moment, I'm conducting a study of both fathers and mothers. We recruit them before they are thinking about having babies. We help them have and we scan them at that point. We help them have babies. No, they do that themselves. And then we scan them just after birth again to see how their brains have changed. And then we scan them again 12 months later. And we don't just scan them. We look at all kinds of behavioral measures as well. So that will potentially be the first kind of study of understanding of how it is that it changes. And then, of course, the question becomes, what happens when that most natural of all things sets in, namely sleep deprivation? What happens with severe sleep deprivation when you're interacting and trying to act on those kinds of cues? So it all sort of stemmed from an observation I did a few years ago using this particular scanner, which is a wonderful scanner that allows us to look over milliseconds of what happens in the brain. So looking at the electrical signals that are going on in the brain, we were able to basically look at how things were flowing across the brain. So the usual story goes like this. When you see a face, you basically have information coming in through your eyeballs. It goes to the visual cortex, which is in the back of your brain, and it then moves forward in both what was called the dorsal stream and the ventral stream. The dorsal stream is all about where your faces are out there, and the ventral stream is all about what it is that you're seeing. So the late Oliver Sacks, the great Oliver Sacks, wrote a book that some of you may have read, which is called A Man Who Mistook His Wife for a Hat. And this is really about an individual. It's a story about many individuals, and of course, in a very empathetic way, Oliver would tell you about what it's like to be on the inside of many of these neurological syndromes. And in this particular syndrome, there's a man who has a problem with his fusiform face area, the part of the brain that tells him there's a face out there. This is why he mistook his wife for a hat. This is why she suddenly, he was unable to recognize her face. So what I had expected when I started to see what happens to adults who are not yet parents when they were looking at babies was that I thought that I would see activity to infant faces in the fusiform face area, and later on I would move into the reward areas. So move on to the parts of the brain like the orbital frontal cortex that's involved with food and sex and other social stimuli. But that would happen much later. It would happen probably much later, of course, in brain terms is about 300 to 500 milliseconds, so about half a second later. While the actual initial impulse in the fusiform face area would happen after about 130 to 170 milliseconds, much faster than we can in fact consciously perceive. So imagine what happened when I put them in the scanner and I found this. I found equal activity to infant and adult faces in the fusiform cortex, which is what you're seeing at the bottom there. You can see the red tells you that's time 0, and then you can see there's activity in different frequency bands. So there's no significant difference between the two lower quadrants over there. But look at the top left quadrant. There's a lot of activity in the reward system, in the orbital frontal cortex, just over the eyeballs. I'm showing you the brain seen from below. In this part of the brain that we know is involved in rewards, that we know is involved in actually making the right kind of appropriate responses. But it's at the same time, which was much of a surprise because, of course, it can't be an evaluation. It has to be something else. It has to be what it is that draws us to these babies. That's why we tentatively thought that maybe we'd stumbled upon the parental brain signature, something that basically allows us to find out that there are interesting things out there, and then we really need to look out for them before we become aware of them. So obviously that was worth investigating further. And so using these deep brain electrodes that we use for patients and other, as I told you about how we put them in for chronic pain, if you have a pain in a phantom limb that is no longer there, and you stimulate deep in the brain in the periacadoxal gray, which is what I'm showing you up here in blue, you can basically, if you stimulate at 30 hertz, you can make that pain go away completely. Now, if we change the stimulation on table when the patient's awake and we've got an electrode and it drilled into the right place, at 50 hertz, the pain comes back. At 90 hertz, the pain becomes unbearable. So this is pretty exciting. Of course, it shows us that pain and pleasure are intimately connected in the brain. I then had this mad idea that if these babies are really so amazing, the sound of them must be something that draws us immediately. We know, and some of you will have been on an airplane here, and some of you may even have had that little baby who was crying, and you feel really awful about it, partly because you really want to go and tell the parents how to calm the baby, right? It's very difficult not to have that impulse. So I thought, why not use these electrodes not to stimulate, but to record from this part of the brain, to see how quickly we actually, in this most ancient of the brain, part of the brain, will react to these things. This is the fright and flight kind of circuitry. This is what, if you have a traumatic event happening to you, this is why you may freeze or you may start to fight or do other things. And again, only after the fact, and of course this harks very much back to the discussion earlier, is when you then come to reflect upon that, when you then become to think about the kinds of reactions. But these reactions are difficult to control. So we stuck an electrode in there, or the electrode was already there, and in 4 people, of only 1 was a parent, we recorded from the periacadoxal gray. And we found that within 50 milliseconds, fairly fast, we were basically able to record a very significant difference in the LFP, so in the electrical potentials from these electrodes to the sound of a baby, whether it was laughing, whether it was babbling, or whether it was crying. suggesting that just the mere sound of a baby is something that immediately grabs us by the throat and basically makes us attend to it. This, of course, is in the normal brain, and the question is what might happen if it wasn't normal. But still, you know, the brain is not just one part of the brain, and so we use the giant hairdryer to look at what happened when we actually listen to baby crying. And here's just a sort of evolution of how it is that activity gets in from the brainstem into the primary auditory cortex, which is the kind of blobs that you see circled in blue. But again, around 125 to 130 milliseconds, we get this activity in the orbital frontal cortex to the sound of a baby, mirroring what happens when we look at a baby. Again, suggesting that there's something almost pre-attentive about the way babies look that cannot stop us from actually engaging with them. So that's pretty exciting because, of course, that I think tells us something about the nature of this kind of binding. So how does music and dance link into this? Here's a study from Blood and Sartori from 2001, not made with something as time resolute as MEG or hair dryers, but made with PET, which of course is the kind of technique that takes minutes to look at. So this is really an average over a minute of activity. But they did something very clever. They took people and put them in a scanner, and they took their favorite music, and then they waited for that moment that just got the hair rising on end, the chill moment in that music, whether it was Tchaikovsky or whether it was something else. It may even have been Four Seasons. Interestingly, though, one of the things they didn't look at was the kind of pleasure that you get from funky music. The problem, of course, I think, was mainly that they were in a PET scanner and you have to stay really still, and it's very difficult to stay still if you're listening to James Brown. But when they then looked at the chill moment compared to what happened when they were still in the music, but other people were listening to their music and weren't getting the chills, what they found was that the whole reward system was active. The whole part of the brain was again becoming active, suggesting again that music at least is engaged with that reward. And then what about dance? In a famous study by Julie and co-authors, they looked at what happens when you are observing dance. Because, of course, one of the problems with dance is that we can't really put these caps on people. Well, we can put EEG caps on them, but that doesn't really tell us necessarily all that much because the artifacts are so great. So Julie and co-authors did something quite clever. They took experts in dancing, whether they were classically trained, which is what you see on the right, on the top, or whether they were capoeira dancers. And they then made various sequences match for movements, and they got them to look at what was happening. And when they were just looking, this is what you see on the top, what you find is that there's a whole network of regions that is about mirroring yourself into the actual dance. And interestingly, of course, what you can see is partly the sort of the mirror system of the brain, but also notice how the part of the brain, the frontal part, is very much engaged. And in fact, if you look at the regions that are engaged when you're looking at something you know and that you like and that you're interested in, if you're a capoeira dancer, it's the capoeira. If it's the classical dancers, it's the classical. What you get is this part of the reward system, the orbital frontal cortex, engaging. Again, speaking to this unity, perhaps, of dance and music in the brain and how it is that they are engaged. But also, of course, speaking to something that I'm very interested in from the point of the parental brain, namely the role of expertise. What is it about expertise that engages the reward? What is it about of having that pleasure or having that not so pleasure? Because, of course, one of the key things about being an expert in something, if any of you are experts in dancing or stamp collection, is that you're constantly looking for errors. You're constantly trying to predict whether what is happening is what it is that you've got in your head and what might happen next. So going back to the hardest working man in show business, James Brown, remember how we got the top of the U shape. We sort of realized that there was something interesting about that particular kind of syncopation that really got us in the groove. So we put them in scanners, but in order to move beyond neurophonology, we use something called whole brain computational modeling, which is something I've developed with Gustavo Deco in Barcelona, which is perhaps too complex to really explain to you in full details today, but the knob of the whole thing is that the brain consists of wires that are connected to each other. So think of, say, a road map. Think of the périphérique, think of Paris. Think about how it is that there are roads and there are traffic flowing on those roads. Think about if you did snapshots, you could see that probably most of the traffic, most of the time, is happening in the périphérique. If there was a problem with the périphérique, if there's if there's something, that big accident, then suddenly traffic would have to flow in different kind of ways. And this is really what we're doing. We're building a skeleton of each individual brain using something called DTI. We parcellate that into a slightly smaller problem. So we have, instead of having thousands of, or millions even of neurons, we're parcellating them to hundreds of regions. And then we'll try to make models that can basically fit that and try to understand how it is that those things are engaged, how it is that we can make a model that can predict what happens. So this is pretty exciting because it means that we can now start to actually work out, when we're looking at patterns of activity, what is the effective connectivity? What are the parts that are actually not just correlating? So if you feel something is nice and you get activity that correlates with that, it could be just a readout of some other processes, or it could be what is causing something else. And by using this method developed with Matthew Gilson, we are basically able again to measure the effective connectivity. This slide is slightly complex, it's got lots of different kind of colors on it, but really the take-home message is that we can take different networks and we can basically reconstitute the way that traffic is flowing. So if you look at the left bottom, you can see traffic is not just unidirectional as in the top, but we can basically reconstitute using this clever method. And when we use this clever method, and you have to take my word for that it is pretty clever and I think pretty groundbreaking, we can actually do these tuning processes and we can use these noise diffusion network models to basically look at what happens in low syncopation, in medium syncopation and high syncopation, and we can look at what we call a metastable state. Now it turns out that when the brain is working optimally, it is what is in a state called metastability, which is a bit like when you're in a moment. Yeah, I'll finish up in a moment. When you are in a moment of where a small push would either take you that way or that way. And it turns out that this metastable state is exactly what happens when you're in that groove state. And so when we use this method, and I'm just showing you this, and when we then plot that on the brain, we get these regions that seems to be probabilistically active when you are in the groove state compared to when you're either in the low syncopation or in the high syncopation. And if you look at that, and you remember that slide I showed you earlier about the pleasure state, I think this is pretty exciting, that this method actually picks out the frontal regions that we know are engaged with the reward circuitry. But notice the word on top, the eudaimonia. Notice how we've also got activity in the back of the brain, in the peculiars and other places, which we know are probably more to do with meaning making, because of course pleasure is not everything. In fact, meaning making, happiness, is probably the most exciting things of all. So Aristotle talked about hedonia and eudaimonia. I've been telling you mostly about hedonia, but eudaimonia, the life well lived, the kinds of a meaningful sense of engagement. The contention here is that music could be a key to that. And in fact, by just looking at the groove state, we've actually got an insight to that, probably the first insight of measuring that. And that means that we can use these kind of tools to understand what it is that goes wrong in neuropsychiatric disorders. And notice we can't really use mice or rats or even monkeys to look at these states. These are potentially uniquely human states. So we need to use something like this in order to get further in that. But also if we think about the collective, if we think about what we could do with those babies, because of course there are ways in which it goes wrong. Here's an orphanage in Sao Paulo, photographed by Sebastião Salgado, one of the great photographers of the world. But on the right here, I show you the incidence of postnatal depression, and they're very high. Places like Malawi have between 30 to 40% of young women. Now, there are very simple, low-cost interventions that we can design and deliver that would actually make life a lot better. So one of the things we're committed to is doing that. And one of the things we're looking into at the moment is trying to see whether we could use music for that, whether we could use music as a way of grabbing the attention of the mother and of the child. But even more so, what about empathy in general? Here's a good friend of mine, Roman Kasnarik, who's written a book called Empathy. Initially it was called A Guidebook to a Revolution, because empathy, of course, is not really just a fussy kind of nice kind of thing. It's something that can start revolutions. It's about trying to actually walk a mile in your shoes. And one of the things we do in this museum is that we make pop-up museums. And here's one that we made in London, where we asked people to come to this and go into the shoe shop, and they were given a pair of shoes and a set of headphones. And they literally got to walk a mile in somebody else's shoes. Whether this was somebody who had suffered from one of the London bombings, or whether it was a convicted murderer, or whether you name it. There were lots of stories, and people were really, at least by their own account, were changed by this. They suddenly saw that things could be different. How is it then that these things, how their reward circuits are changed by this experience? Could this potentially, although here of course applied in an art kind of sense, could it be something that could help us make useful interventions? So what have I told you? I've told you that I think in order to understand collective emotions, I think it's worthwhile to look at the sort of template for this, the parent-infant relationship. And understanding that could potentially make us understand what it is that happens in distress. It could also potentially help us build new interventions and potentially use both music and dance as a way of actually digging into this very human of emotions. And furthermore, I think it might actually give us an insight into eudaimonia, into happiness, which we're lacking at the moment. But much, of course, remains to be done. I've been very interested, if you want to read more about this, you could read my pink book, although my colleagues in Oxford look at me and say, "Are you sure that's science, Morten?" And so when you do that, you have to come up with a magnum opus, which is the one next to it, called Pleasures of the Brain, where we've asked the world's experts to give us the sort of the gory details of pleasure. We should also think about consumption. We should think about whether that really makes us happy, and we recently edited a book showing us that that probably doesn't make us happy in any sense of the word. It's almost like that wanting state, that addictive state that I talked to you about earlier. We could also think about the temporal things, the way that the brain is changing over time, and I think that's very important. But I should probably end here, and I should thank my team and my collaborators, and thank you.
So we move on to the next talk from Julie Grèzes about social function of emotional displays of fear and anger.
Okay, so I'm going to talk about the social function of emotional displays of fear and anger. And just to start, I'm not a social psychologist, I'm a neuroscientist, so of course we're going to change scale. And different scales. The first one is the time. I mean, when I heard Bernard yesterday talking about days, weeks, and months, I was thinking, ooh, what am I going to say to those guys if I'm talking about something that happened in the first second in the brain of people when they perceive other people expressing fear and anger. So that's the first shift in scale, so time. And then also, you know, I'm not working with this technique. It's very difficult to study collective emotion per se. So I hope what I'm going to present you is going to tell you something about the mechanism that already happens between two persons. And we can try to understand how maybe it can go to more group events. So the background I'm taking is a evolutionary framework whereby emotional display have a communicative function. So we know that emotion and emotional expression have an intrapersonal function. They're going to help us. For example, fear is we are going to have widened and open eyes. Same for the nose. So you're going to increase the intake you have from the words, but we also have they also have a communicative function, and I would like to talk about this today. So what we know is that they're going to inform, communicate important information to others, and the goal is to influence other people's motor behavior. And so if we take this as a start, we could hypothesize that they have co-evolved with the action in the recipients. So the idea is that while one person is going to send the signals, the recipient of that signals is going to, one, decode this relevant information, but more importantly, is going to use this information to adapt his own behavior. And this is something we propose with Guillaume and Pierre Jacob in a recent paper. So what is the information that is available in the environment as an observer? So we have the emotional expression displayed by another person, but this emotional expression is rarely on its own. It's embedded in a context, whether the context is the body of this person or even the scene in which it's expressed. And today I'm going to concentrate mainly on gaze, and in a way I thank John this morning for his talk, because he already introduced self-relevance at a quite high level in terms of identity, self-identification with others. And here I would like to see whether, you know, how the context is going to impact how self-relevant an emotional display is for the observer, and how it's going to impact on how he processes that emotional expression. So what we know is that the body is already a context of emotional display, and if you look here on top at the facial expression on its own, it's not going to tell you enough information to understand whether that person is losing or winning. It's the help of the body expression that is going to, in a way, make the expression less ambiguous. So context is going to help us to disambiguate the emotional expression, but also it can change the meaning of the same expression. And we know that about gaze direction, for example. So we know that certain combination of gaze and emotional expression are going to take different meaning, or are going to be more or less relevant, although we need to talk about relevance one day, because it may be a loose concept. But what we know is that, for example, here, so let me take this maybe. What has been shown in the literature is that if I show, okay, that doesn't work. So if I show an angry facial expression associated with a direct gaze, or the same angry expression but this time with an averted gaze, people are going to be better and quicker at recognizing the first one, which is direct gaze associated with an angry expression, than the reverse. But it's going to be the reverse for fear. So people are quicker and they better recognize fear when this time it's associated with averted gaze. So why so? Some people propose that maybe because anger directed at you is more relevant, self-relevant for you as an observer, and it's the reverse for fear. If somebody has an averted gaze, it may tell you something about a danger, a potential danger that is in your environment. So what we've been showing in the team is that indeed, you know, those two, what I'm going to call relevant for the moment, relevant condition, which is anger direct and fear averted, are going to attract more attention from the observer, and therefore they're going to be better, for example, to a task whereby I superimpose facial expression with a house, and you're going to be better at detect the house, maybe because you give more attention to those two relevant conditions as compared to the other one. And what we also show is that if somebody is looking at you while expressing anger, you're going to have more facial expression. So you're going to react more in terms of your muscle activity, only when the person expresses anger towards you as compared to express anger towards another person. So there is something here about, you know, the relevance of this combination of emotional expression and direction of the gaze or of the body towards the observer. But what we are interested in the team is the link between how an emotional display not only informs somebody about an important information, but also has co-evolved with the action in the observer. So the fact that it's going to force you to adapt your behavior and also prepare a motor response. So the idea is that the more the information is relevant for you, the more we should have a trace in our motor system in the observer. So how can we test that? So I'm going to present two experiments. The first one, or maybe three, but the first one has been done by Marwa El-Zain in the team, who's behind here. And we did a very simple categorization task whereby we presented to people emotions, so anger and fear, associated with a direct or an averted gaze. And again, the idea is that we're going to play with the relevance bias doing this different combination. And people see the faces for a very short period of time, 250 milliseconds, and they have to tell us, is it fear or is it anger? And the first thing is that we replicate the literature by showing that the most relevant conditions are the ones that are better categorized. So anger direct and fear averted are better categorized than the other two combinations. But this is not enough to tell us about what's going on in the brain. So what we did is we recorded the EEG, so the electric response over the scalp of the people while they were doing this task. And this is a bit of method, but what you have to know is that we do not show only those 4 figures, but we show a morph each time for each expression. So it's going from neutral to anger or neutral to fear in 7 different steps to have a bit of ambiguity in our face, and we change the gaze, sorry. And what we look in the brain is not just the response of the electrodes to those situations, but we look at the correlation between how strong is the emotional display and the electrode response. So what I'm going to show you now is how much correlated is the brain response with the amount of intensity in the brain. I'm not sure I'm clear, but maybe I shouldn't go too far into the methods. What I want to show you is there is 2 messages, in fact. First is that in 200 milliseconds, the brain is able to decode the emotion that has been displayed in front of the person. And the more the emotion is strong, the more you have a correlation in your brain and with this emotional strength. But what's important here is we wanted to see whether the brain encoded differently what we call relevant and less relevant condition. And what you can see here is that so negative and positive is not very important here. It's the difference between relevant and irrelevant condition. And what we can see is that relevant conditions are going to be better encoded in the brain than less relevant condition. So the brain is susceptible to this combination between gaze and emotion, and the more relevant the condition is for you as an observer, the more activity you're going to have in your brain when you perceive those emotions. This happened in what we call phase selective regions, so we heard about that just before, in the fusiform gyrus, which is known to encode identity of the face. But what I'm interested in, again, is not how the brain decodes emotion, is how we adapt our behavior when we perceive other people's emotional display. So what we did with Marwa is we also looked at what's happening in the brain at the level of the motor cortex, which tells us something about how the person who is observing those emotions is preparing a motor response. And what Marwa shows is that in 200 milliseconds again, so this is very quick, so you have an answer in the ventral pathway, but in the dorsal pathway that helps you to prepare an action, you have a difference between perceiving something that is relevant for you as compared to irrelevant. And what we show is that only relevant conditions, so again, anger directed at you or fear with an averted gaze, are encoded in the motor system. And the less relevant, the non-relevant conditions are not encoded in terms of the motor cortex. So this is important because it tells you that, only when there is something that is self-relevant in your environment, your motor system is going to start to prepare an answer, a motor answer. Of course, this is during a behavioral, just categorization task, so we don't have the proof that actually, people are really prepared to do a motor action. The other thing we looked with Marwa is difference in anxiety. So here it's state and anxiety, and you could take that as a state of fear, although we know that there is big difference between fear and anger, but it tells us something about the state of the person and in anxiety. So what we show again is that there is a double dissociation. So I've shown a dissociation between the ventral pathway and the dorsal pathway and what prepare you, but Here we also show that anxious people have a sort of hypervigilance, which we know is a classic hypervigilance, meaning that every event in the environment are decoded as potentially threatening. So this is not new, and non-anxious people clearly make the difference in this ventral pathway between what's relevant and irrelevant. So that's not very new. What's new is what's happening again in the motor cortex. In the motor cortex, only anxious people encode relevance in terms of motor preparation. So the more you're anxious, the more you're going to perceive relevant events in terms of, I need to prepare, I need to answer to that person, and they are more prepared to react to relevant conditions for themselves. So that's the first study, which, you know, give us again an argument that probably emotion have a communicative function, and they probably co-evolve with the motor answer in the observer. But to really demonstrate that, we need to also show a second step, which is the behavioral response that we see should reflect the social function of the emotion. And here I can only tell you about how the motor system has been activated more for relevant than irrelevant, but this is for both fear and anger. So I don't have really the argument to say this is dependent on their social function. So I think we have a fair amount of argument here to say that there is a specific answer that is associated with specific emotional display, and one of it is this sort of, you know, approach fear, which is not which is quite intriguing. So this is something we were looking for with Guillaume before, and we're trying to understand with Emma now what can it means. So the first thing that we know is that fear on the perception side is very often associated with submissive and highly affiliative traits in terms of what they mean for people in terms of perception. So they are viewed as social signals that convey vulnerability and maybe a need of assistance. And we know that also in other group living, like monkeys, that fear display function to inhibit aggression and elicit prosocial behavior. On the response side, what we know from the literature is that consolation behavior toward distressed others is observed both in humans, monkeys, canids, birds, and recently Burkett's and all have shown that in mice. So as soon as a mice express distress, another one is going to come and groom it to affiliate, to low down the distress. We also know that fear or induced anxiety produce an increase in affiliation, and the presence of affiliative conspecific is going to reduce stress. So, I mean, again, you know, coming back to what Guillaume said this morning, there is this idea of does fear spread, or does it drive helping or affiliative behavior? There is this tension between whether you want to flight or affiliate with others, and in the proportion of choice that we have, we can see that it's really 50-50. People have a sort of, they do, half of the time they avoid the fear and half the time they're going to approach. What we know is that there is this classic tension between your individual and collective interest, and maybe this is what's happening, I don't know. So what I would like to do with Emma is to try to replicate which I just showed to you in a different context. So maybe a context that is more threatening, or maybe where one of the choices is going to be more costly for you to see whether you're still going to do this approach behavior towards fear. But I think those two studies shows that there is a communicative function of emotional display, and potentially those emotional display have co-evolved with adaptive action on the side of the receiver. So as I say in my introduction, I hope you know this tells us a bit of the mechanisms that happen in between two people, but what can we make for collective behavior? I don't know if I have much to say now, but I'm going to try to give some pistes in a way. there is something that I really like in the literature is this idea, and Laurence talked about that yesterday already, this idea that we co-represent action space of others. So not only I have a map of my own action available all the time in my brain, but as soon as somebody is around me in my peripersonal space, I'm going to take into account other people's potential action. But what's interesting in regards with what John said this morning is that, you know, it's going to depend on my identification with others. And there is a recent paper showing that it doesn't work for out-group members. So you're not going to take into account other people's potential action if they are from your out-group. And I think it's a very nice study that goes, you know, make a link between what we are doing at a dyadic level, but taking into account this sort of self-identification to a group. The other thing I want to tell is that Guillaume, during his PhD, did a very nice study whereby he looked at facial EMG, so how your muscle reacts to other people's emotional display. But his goal was to go beyond diets and show that there can be a transmission of emotion beyond diets. So he built a paradigm whereby C look at B, who look at A, but C has never access to A at any point. And what he shows is that if you record what's happening in C in terms of his facial expression, there is a transmission of emotion from A to B to C. So even though it's not explicit, if then you ask people to judge what's happening in B, they can't really say what's happening, but it's still enough to be transmitted in C. But we don't know what happened, what's the influence of self-relevance or, you know, self-identification of group membership on that kind of transmission, and it would be nice to have the same experiment between in-group and out-groups. And the last thing I would like to say is I discovered a bunch of papers that I found very interesting. It's not about being a crowd, but it's about seeing a crowd. And Sweeney and colleagues have done a number of experiments that are very interesting, whereby he shows that you're very good at detecting and in a way averaging what's happening in a crowd. So what he shows is that if I show you this, you're almost quicker to determine the gaze direction of the crowd if there is many people than only one. You're also very good at detecting, at having a sort of average image of the emotional display of all the crowd. And because you do an average very quickly, you're also very good at detecting any variance from that average. So it's going to help you detect anybody in that crowd that is going to behave differently. And I think this is a very interesting work on which we could build from what I show you. But again, in-group and out-group has not been taken into account here. So it would be a next step. Thank you.